Welcome class, this is lesson 57 or activity 7.1. We're going to be talking about advanced dimensioning. This is the first lesson in unit 7, which is all about documentation of various kinds. This time we're going to talk about dimensions and drawing files. This video, if you are on Flipped, is due before Thursday the 4th and Friday the 5th. So I'm going to skip over some of this stuff. We're going to talk about it in class. The first thing I want to talk about is standards institutions. In the engineering world, you have so many different standards. Remember, we wanted to go over the right side view instead of the left side view. That's just because that's why we do it, or that's just because that's how we do it in the U.S. In India, it's backwards. That's just because that's what we decided. It doesn't really matter. We just picked one. Negative current is carried by by electrons. It doesn't really matter. It could have been positive. But it's that's just the way we decided on it. Just like actually all of math is standards that we've decided upon. They happen to be very, very useful, but we've just decided on all those standards, and so we like to keep those standards standardized throughout the world. So here are some of the standardizing institutions that we use. ANSI, ISO are the big ones. ANSI and ISO. There's also ASME, the American the American Society of Mechanical Engineers, that creates some standards for our dimensioning, but ANSE is American and ISO is international. That's the big difference there. The U.S. military has a few standards, a couple of standards here, and then there are some international standards here, German, Japanese, and European. Next, I want to talk about where to put dimension text, but before I do that, I want to talk about some of these terms. We've gone over extensively. We've gone over extension lines. Those are the lines that extend the object lines, and dimension lines. Those are these lines with arrowheads on the ends, and then this is the dimension text, just so you're aware of what I'm talking about in a second. So this dimension text, if we notice that it does not fit between our extension lines, we definitely want it to be outside the extension lines. Also, we want our dimension text to always be aligned, or excuse me, in the middle, horizontally and vertically. It doesn't matter where it is. We want it aligned. We want it in the center, both directions, horizontally and vertically. So there are two different types of methods of putting our dimensions in here: unidirectional or aligned. Unidirectional and aligned, and here's the difference between those two. Unidirectional, the text itself can be read from just from looking at it. The aligned dimensioning method, you'd have to actually turn your head to read it, or if you're kind of smart, you can read it from looking straight at it, but the text is turned in the aligned version. Also, on an angled dimension, if you have that there, for instance, that would be aligned to the text, aligned to the object line that you're dimensioning. So the text would be angled there too. Okay, those are the two methods, unidirectional and aligned. In unidirectional, on that angled line, your text would still be horizontal. So let's talk about some different dimensioning styles here. Before that, I should mention there are two different types of dimensions. There's a size dimension and a location dimension. So this is a size dimension. It's telling me how big this product is, and then these are locations telling me where exactly the hole is located. Remember, you want to dimension a circle or a curve, a radius, from its center. You want to tell me how far over the center is and how far up and down the center is. So you need location dimensions as well as the size dimension of the circle itself. So like this right here, this is the radius, and so that would be a size dimension as well. So the two the two styles of dimensioning are chain and datum. Chain is what we talked about before. Remember, we don't actually like this chain dimension where it goes this dimension, this dimension, this dimension, or in the case of these steps, step 1, step 2, step 3. Or down here, step 1, step 2, step 3, the heights. We don't actually like chaining them all the way up from end to end. We like this method better. This is still a chain dimension, step 1, step 2, and the whole. So we leave off the third chain, but we make sure we have the overall dimension here. Remember, this one does not have the overall dimension. We don't like that. We prefer the overall, and then this last one to be inferred. It's better that way because it limits manufacturing inaccuracies. If you know the entire the overall dimension straight off the bat, it's better. So the second style is datum dimensioning. So datum dimensioning is different from chain. You're not going to dimension the top, the middle, and bottom step. You're going to dimension all of these lines, how far away they are from one reference point or a common point. That reference point is called the datum. The datum. So this first step drops off half an inch from the datum or from the left side. The second step drops off 1 inch from the left side, and the third step drops off 1.5 inches from the left side, or half, 1 and 1.5 inches from the datum. And down here, the datum is the bottom. That makes sense. So this bottom left point right here is the datum on each of these views. Let's talk about some symbols here. We should have already seen a lot of these, not all of them. Diameter and radius, those are big. These are counterbore, spot face, countersink, and depth. We're going to talk about those in a later lesson when we get to holes. Reference symbol is very interesting. We'll talk about that in a bit. And then let's see, we'll talk about this one in the very next slide, places or by symbol. So the X indicates the number of places or occurrences. So 2 occurrences or 2 holes is what this is saying. Instead of putting all this information, this by the way is a counterbore symbol. Instead of putting all this information over here and over here, you just say 2x. So there are 2 of these holes that are exactly the same. Pretty nice. Let's talk about dimensioning some various features. For instance, an angle. As I mentioned before, you could do an angle down the side, and that's not really what we like. We like either a coordinate method or an angular method. These are really the 2 types of the 2 methods for identifying any point in math or science or anything. This is a coordinate system. Rene Descartes came up with this, so we call this the Cartesian coordinate system. You just tell me how far a point is from in 2 dimensions, 2 directions, up and down and left to right. The theory or the myth is that Rene Descartes was sick, and being a brilliant man, he saw a bug on his ceiling, and he said, how can I identify where exactly that bug is? And he thought, well, if I take a reference point, the corner of my ceiling, and then I say it's so and so feet to the left and then so and so feet up, then I know exactly where it is at every location. So and so feet over and so feet up. You can find both of those points, and then this angle is just inferred from, if you know both of those points. It's the line that connects them. Over here, you don't have this point exactly identified, but you do have the angle of this chamfer going on here. That's the 2 different methods there. Let's talk about dimensioning the chamfers themselves. If you have a 45-degree chamfer on the external, then you can dimension it in 2 different ways, 45 by 1.25. And I had to look this up because this is a bit confusing. This 0.125, this 1/8 of an inch, is that the entire length here, or is that the distance from the bottom to the top, from this point to the top? It's actually the distance from this point to the top. It's not the length, okay? It's not the length. It's the distance from the bottom to the top. That's why we have an 1/8 and an 1/8, because it's from the bottom to the top and from the, from this point to the top and from this point to the right, okay? 1/8 of an inch and 1/8 of an inch, they're going to be the same because it's a 45-degree angle. Over here, you can't do that. You can't say 0.13, 0.13, because they're not both 0.13. It's 0.13 on one side and then a 30-degree angle. So for any angle other than 45 degrees, even if it's less or even if it's more, you're going to want to have one length and one angle. That's basically the angular method we talked about before. Internal chamfers are the same way, except that the difference here is in this one you have 2 extension lines crossing, in this one you have an extension line crossing a dimension line. That's a little bit annoying, but that's what we have to deal with in an internal chamfer. Okay, so when you dimension circles and arcs, remember that you want to dimension it in the view that shows the circle and arc. That's from the dimension guidelines from before. Arcs are dimensioned by radiuses. and sometimes you want that center mark. We'll talk about that in a second. Circles are dimensioned by diameters. Circles are dimensioned by a diameter. So let's look at some arcs. Arrows can be inside or outside of small arcs. Before a big mark, you need to put the dimension on the inside, and you should have a center mark for that large arc. Okay, so for a large arc, you need a center mark. And remember, arcs are dimensioned by the radiuses. So for fillets and rounds, it's kind of the same thing. They're arcs, so you need to dimension big ones with center marks. But rounds are usually on the outside and fillets are on the inside. This is a bit misleading because in Inventor, it says fillet and it allows you to make rounds. So the fillet tool allows you to make rounds, but we like to clarify the distinction. Fillets are internal, rounds are external. Okay, let's talk about dimensioning circles. Again, we want to dimension it by a diameter. Holes should use hole notes. It's really good practice to say how deep your hole goes, unless it goes all the way through. We call that a blind hole. We're going to talk about that later. Then you can say THRU, through, and then we know that it goes through all. So full circle should be dimensioned using the diameter. This hole note specifies a hole with a 1/2 inch diameter and it's 1 inch deep. So this tells you how big the diameter is. This tells you how deep it goes. Okay, then cylindrical parts should be dimensioned on the faces that are not circles. So only on cylindrical parts should you dimension it like this, not on circles. On regular circles and holes and stuff, you should dimension it on the face that shows the circle, but not on cylindrical. Let's look at a spline and a curve. This is a really cool tool. This is a really cool method here for a really nice spline. There probably is a really cool mathematical model that will fit this curve, but instead of doing all of that, we can just say, hey, these from this datum over here, we can go up and across to several points, and of course the more points we put on here, the more accurate our curve or our spline is going to be. Here's an example. We chose this point as the datum. Here's an example from real life. This is the windshield of the Automoblocks. And so we said each point goes some distance up and some distance over from that datum. These vertical dimensions here are reference dimensions, and like I said, we'll talk about that a little bit later. Okay, finally, dimensioning radial patterns. I'll let you see if you can figure out what is the missing dimension here, because all of these circles have angles from the horizontal or vertical. You know, this one is 45 degrees over that way. It's 45 degrees from the horizontal as well, so that's a little bit redundant, but there's a size of this circle. There's actually a size of the circle that centers all of these. That's why it's kind of a center line going on here. But there's one big dimension that's missing. I'll see if you can figure that out. That's about all we have for that. I'm going to go over to Inventor and talk about the assignment real quick. Okay, here's the assignment. This is the same Google Doc that you guys have in Schoology. Don't forget to read all the introduction, the equipment, make sure you have Inventor Professional 2018 and the dimensioning guidelines from before. So on this part, you should have already built this in Inventor in 5.6 or sometime else. I think we might have done it in Unit 4 instead. But you should find that part in your H drive. If not, you'll have to build it again. It's no problem. It's pretty easy. Don't forget the grid spacing is 1/4 inch. Make sure yours is aligned with that. And then you can get all the dimensions from the grid spacing here. You will need to create a drawing file and make sure that it has datum dimensioning and align the dimensioning for this part. For some of the other parts, it'll be different. It'll be chain dimension, and this one is chain and unidirectional dimensioning. Then this one, I want to use the coordinate method instead of the angular method for measuring these chamfers, and make sure you have datum dimensioning on here. Then the bonus is creating this part, then creating a dimension drawing, adding both the part file and the drawing. Then for some more extra credit, excuse me, this was extra credit. Then for some more extra credit, it's some of your parts in from the reverse engineering project, datum or chain. You need to tell me datum or chain, align or directional, then give me the drawing files. Don't forget the conclusion questions are 2 to 3 sentences each. Okay, so over here, whenever you create this, let me jump over to Inventor and show you how it goes. Okay, first things first, we want to make sure we're in the right project. So let's create a new project, new single user project like before. Next, let's make sure this is named. I want it to be called A7.1 underscore project and underscore your initials, first, middle, and last, not MBH, that's my initials. Don't put it in the C drive. Browse to the proper location, go to this PC and scroll down. You should see your name right here. That's your network drive, your H drive. Mine doesn't have it because I'm on my laptop at home. But make sure you're not in the C drive. Do as I say, not as I do. Finish this. And I actually have one already, so I'm going to use mine. Create a new part file, standard part, not sheet metal. Make sure we're in inches. If not, go to English, standard inches here, and then create. This is a style conflict that I'm getting on my computer. Don't worry about it. If you do get it, just hit OK. You should see part 1, but I see part 2 because I've already made one. First things first, save your part. I would save it as 7.1.1 underscore your initials. Mine are MBH. It should show up as an IPT file, but I've already created one, and here it is. Oh, I feel just like Rachel Ray. So I have the thing dimension and everything. I have it built, and now I want to, using this file, I want to create a new file new. I want to create a new ANSI IDW. Okay, sometimes maybe their template just says standard IDW, doesn't matter, just as long as you have inches. Hit create. Now you have this drawing file, but oh no, look, all my numbers are way too small to see at this scale, so I want to change the size of it before I can do that, I need to delete this title block out of here. Now that's gone. I can right click on the sheet, hit edit sheet, change it to an A size, 8.5 by 11. Make sure you change the name of the sheet too. I want it to be A.7.1.1 underscore your initials. Hit OK. All right, now this looks better. We also want to make sure we add a title block ANSI A. How we do that? Just double click on it and it'll show up. Okay, next we have some field text here, but some of it won't let you change it very easily. You have to go up here to I properties. Then you can change some of the things. Let's see, like summary, author. Here's the author. I don't want administrator. I want my name. Let's hit apply and close. Let's see, the drawing number. We can do that with just, I think it would be the part number here. I think we can call that A7.1.1 underscore MBH. Again, hit apply. And then close that. Yeah, so that drawing number shows up here. And then if you wanted to add some general notes or something, or the title, you can just, of course, go to annotate and then add some text. And you can kind of mess around with how that text looks. But now that we have our sheet set up, we're ready to place some views. Of course, we want to place the base. And fortunately, if we're in the right folder and everything, our part that we just created should show up. Then we want a front, obviously, and then a top, and then a right. You could put a isometric here, but the main thing that we want to worry about here is the scale. 1:1 looks kind of small. Our dimensions might be read a little bit small. Let's see what a 2 looks like. Yikes, that's a little bit big. Let's try 1.5. Okay, that's probably pretty good, but we want to make sure all of our parts, all of our views are not obstructed by the title block. So to move it around, let's click on that dotted outline here, and so we can move this a little bit up to out of the way. It's kind of it might not be so good to be obstructed by the border here. So actually, in fact, I'll double click on that and change that back to a 1:1 scale, or maybe a 1:3 scale. That might be better, at least for the isometric view here. That's view 4. Then I can maybe pull this down a little bit. So now we want to add some dimensions, which is the big money item of this assignment. Go to Annotate tab, hit Dimension, and then we'll click on something like this. Obviously, this is the overall height of the part, and we want to add that dimension there. Fortunately, the number is already there based on what we created, so we just hit OK. Now, this is the tricky part. I gave you some instructions of how to do this right here. If you read all of this carefully, you should be able to figure it out, but let me just go over it real quick. So this dimension is it's unidirectional and not aligned. On this first part, we want to make sure that we are doing a line dimension, so this needs to be a vertical text. So how do we change that? Well, of course, we need to be outside of the dimension tool before we can edit anything that's existing. So let's cancel. Then we can click on the dimension and right click on it. Now what we want to do is actually add a new dimension style. Add a new dimension style. You can see up here it just renames it default ANSI 01, which is exactly what we want. Under text, we want to make sure that our align dimension is align, inline, and aligned. Inline aligned for an angled, for an angled dimension, and for a vertical dimension like this. Inline vertical and inline aligned. Inline horizontal is already default, and that's how it's going to be for both unidirectional and aligned dimensions. But we want to change this to inline aligned, and we want to change this to inline vertical. Then we want to hit OK, and look, there it is. It's perfectly aligned. But unfortunately, if we want to do another dimension, that is unidirectional. Whenever you create other vertical dimensions like this, you're going to have to go in kind of manually and change the standard here, and it's going to be in a different spot. Of course, you can't edit a dimension when you're in the dimension tool, so let's right click and cancel. This dimension, let's select it, and let's go up here to format, and then we can choose our ANSI 01 that is vertically aligned. You'll have to do that for every vertical dimension to make it aligned, but it shouldn't be too much effort, especially since there aren't a whole lot of vertical dimensions here. There might be some up here in the depth and some not any over here on the height, because we already have the height over here. But that's basically the gist of it. Make sure you take a good screenshot of this, put this in your document, and that's it. Have a good night.